Okay, question 5. How do you move from ln x to 4 ln x minus e? So, first thing I always put down is my translation. Now it's inside the bracket, so it's the opposite of what you expect. It's the x direction, it's e and then naught. And then we're going to stretch scale factor 4 parallel to y-axis, in y direction. Part 2, sketch on the axis below the graph of y equals this, so we've got b here, and the graph below indicating the exact value of x coordinate where it meets the curve on the axis. So what I'm going to do here is just create the graph. Obviously you've got it there drawn for you straight away. So we're going between e and minus e, and we've also got 0 there. We've got y and x. So we're asking to draw this, but it's the modulus of it. So what's going on here then? Well, we've translated it and then we've stretched it. So what scenarios have we got going on here? Well, let's first of all think about the curve in itself. The curve in itself is y equals 4 ln x minus e. Now the one that's impossible is ln naught. So here, when you put e in there as your x, you'll get naught. So therefore this is a value that can never be taken. And the question then is, if you put in, say, something like naught into here, you get minus e. Now can you ln any minus at all? No, you can't. Again, comes up with the same issue. So what we now already know is that here, this is our starting point. Can't go any lower than that. So then what do we expect to happen? Well, the log graph then goes through here and then cuts through at this value and then carries on going when it's at 1. So what this graph will do is, because it's been translated and it's then going to shift, it will come down, hit a value here, and then bounce back in the opposite direction. Now this value here, well, think about what it's going to be. It's when ln, it's when the whole thing is 0. Now you want this to be 1. So how do you make it 1? Well, you put e in, and then you put a plus 1. Because an e will then cancel the e there, and then you've just got the 1 itself. So that's then the sketch done. Part 2, C part 1, solve the equation here where we've got equal to 4. So it'll be equal to 4, so we're going to have two versions here. We're going to have when, if I put equal to 4 going across here on this graph, you've got 2 points of interest, here and here. Now this point here would be exactly the same if you continue the normal curve at minus 4. So what we're going to do is we're going to set, for C part 1, the solution when 4 ln of x minus e equals 4. We're also going to do the other solution where 4 ln e equals minus 4. So we've got ln x minus e equals 1. We are then going to ln both e both sides. So do the same thing here. We'll just work through them all sort of similar stages. Which will then give you x minus e equals e, or e to the 1 if you like. And then this one will be x minus e equals e to the minus 1. So we then have x is equal to 2e, and also x is equal to 1 over e to the minus 1 plus e. So two values there. Part 2, hence or otherwise solve inequality where this is greater than 4. So if we just drop back to this bit, when is the modulus itself greater than 4? It's at this value here. when it's less than that, and it's at this value here when it's greater than that. So if we look at our points, then what are we doing here? So it's when it's 2e, or 1 over e plus e, well that's the smaller value there, isn't it? So it's between, it's when x is less than that, and x is greater than 2e. So we're thinking about that and saying, alright, well, we wanted it equal to as well, so we've obviously got to put the equal to sign in there, and equal to sign in here. Now just going back to the graph itself, we've actually proved that x can't be anything less than e, so we've also got to take that into account here. So it will be when it has to be greater than e as well on top. So it's a hard thing to get fully right, this question, I have to admit.